Okay. Took this thing up off the floor, a little slow getting down and standing too long. Hold still so I can balance this now. Okay. This block is moving on a circle. If I speed it up a little bit, it continues to move in a circle. Speed it up a little, oops, there it goes. Well, that didn't really work because I kind of jerked the apparatus, but as you speed this up, if you keep speeding it up, eventually that block is going to slide off, just like an object on the seat of your car would slide outward if you're going around a curve that's either real sharp at some modest velocity or less sharp at a greater velocity, okay? So when you're moving in a circle in a car, or when this thing's moving in a circle, the velocity, here's a circular path, and the velocity is like this. The velocity of an object moving in the path goes like this, and like this, and like this, and like this, and so forth. Okay, well, between this point and this point, there's a change in velocity. Okay, so let's call this point A, call this point B. So we could say that the change in velocity from point A to point B can be represented this way. Okay, let's say this vector is the velocity at A, and this vector is the velocity at B. And the change in the vector velocity is, one way we can say it is the velocity at B minus the velocity at A. I don't even need a colon there. It's equal because that's a definition of a change from one point to another, right? And we can picture this. So here's dA, and here is dB. Okay, well, this vector we'll call this vector V question mark for the moment, and we'll note that VA plus V question mark equals VB, right? Because of course if you put V question mark head to tail with VA, you get VB. You know, from here to here is the same as from here to here. And that's what it means. Of course, that's how we add vectors. So V question mark is VB minus VA. Of course, V question mark is a vector, so I want to put an arrow over it. But of course, VB minus VA is this, which is this. It's VAB. It's delta V, AB star. Okay, do we understand this? Well, whether we do or not, we need to, right? 'Cause this is gonna be very important. Okay, well, then, what's the average acceleration from point A to point B? Well, average acceleration is delta V.
It's about 11 hours, but you just don't get any growth.
Over delta T.
Doesn't mean the plants die, it just means that they're still inside. Even if you're in a greenhouse, unless it's
Now there's-
supplemental lighting, that photoperiod is a limiting factor in your plant.
A simple derivation that I hope your text will do for you
Giving it up.
that shows that in the limit
Centimeters, a couple of meters here and there, but not any appreciable. So that's what we are looking at. And why we're trying to get out and identify as many plants as possible, especially those that are for horticulture.
Okay, this means that as the time interval from here to here
So this year,
shrinks, well, this vector gets closer and closer to this one, right?
here, those that missed it, and also.
So we can draw a picture
We are.
for small delta T.
Right now, we're at
Here's your VA,
module 3 this week, talking about a sensitive place in Appalachia, which we'll get to in a second. But
and here's your VB.
share this kind of module ID, which is, say here, is running currently through module 2.
And here's your,
So we'll be doing this until we can no longer write the project. Because I want to maximize our time.
delta VAB.
Getting those skills of identifying plants, harvest them and use them. So this is also
Now delta VAB is smaller
value added product project,
than it is over here,
which I will.
but delta T is also smaller. So your magnitude of delta VAB over delta T doesn't change much as you approach the limit as delta T approaches 0. Remember this ratio, as delta T gets smaller, this vector gets smaller.
Over 20 plants.
Also, this is an isosceles triangle.
Plants that we feel really
It's not an isosceles delta, it's an isosceles triangle. It's a little bit ambiguous maybe, but I don't have to write out that whole word. Have to remember how to spell it and everything. Okay. Okay, here's your, so this is an isosceles triangle, meaning the angles add up to 180 degrees. This angle has to equal this angle, right? So you got three angles that add up to 180 degrees. Two of them are the same and one of them is really small. If you got two equal things that add up to 180, sorry, you got, I don't know, three things that add up to 180. Two of them are the same. And the third one is really tiny. That means the two of it are the same, are both about 90 degrees, right? So, the delta VAB, the angle between the angle up here, this angle here, and of course this angle here, both approach 90 degrees as delta T approaches 0, which makes delta VAB approach 0. Okay? Now there's a little more. It involves understanding radian representation and stuff. Hopefully your book runs you through that. Okay? So you want to pay attention to that.
Anyway, so for now, we want to memorize, try to memorize the common name and binomial name for the scientific plants. And I put up Quizlet app for us to kind of practice with.
And I don't want to do that argument in class because my experience recently is people don't understand geometry well enough to understand it all in the time it takes me to do it. So that's why I'm hoping the book does it. It's an important derivation. It's really important.
So that's one way to do it. And we'll make another one of these. I'm going to try to break them down in parts so nobody gets lost.
First of all, this limit is then your instantaneous acceleration. Okay?
Learn today. All right, so any questions there? I'll get this up. Now, some of these probably going to, you weren't here last week, you missed today. What does it do about
It has magnitude v squared over r.
Make sure that it's all the same information on your facts. Eventually, we will have.
That is perpendicular to DOT.
Ideally, out in the field, you know, maybe it's raining or something, we'll do it in the classroom, we'll have a tank there.
When the
I would highly recommend taking samples.
piece of wood slides off of this thing,
Take a picture, maybe make a drawing if you're really.
this thing is moving about this
That
fast.
helps you to connect
1, 2, 3, 4.
that.
About
Maybe if
4
you're-
revolutions per second. Okay? Now actually,
Get that taste.
I don't think it's moving quite 4, but let's pretend it is.
Okay, so there's
Okay.
the current list. There's our, this is over there. Let's talk for a second about Appalachian. This is.
Actually,
this is
that's kind of
gonna be
half
the,
revolution.
sense
So we're going to say 2 revolutions
makes
per
it
second.
For everybody to get a good sense of place wherever you're at. Whatever. As a horticulturist, it's important to be intimately
A wood block.
related to the landscapes around you. Because if you're more related to the landscape, then you also become more related to the culture. And if you're related to the culture, then you can better be a component and a steward of relationships with people. Which is where we make the money at, right? So, a couple of reasons for trying to do that, but also because I think we live in a very special place. Near and dear to my heart. And we'll do a little walk around and get that kind of sense of place.
It requires a centripetal acceleration.
As we work to the south, to the north, gaining a bearing of our orientation, our surroundings, and where we are. But does anybody want to just go ahead and share anything? Just right off the bat about Appalachian? Do you have Appalachian names? Who's a native Appalachian? Who's not a native?
I'm going to say
That will be able to impart on you, who's a native Appalachian?
it's equal to the maximum acceleration
Well,
provided by the centripetal force.
you know, a lot, but there are certain things that I think the hillbilly gets associated with.
I'm going to put a penny on this thing instead of a wood block.
Being an Appalachian. But I think there's a whole lot more stuff that's about.
Okay, so now I've got a penny here. Okay. Accelerating or rotating at this speed, this angular velocity, penny stays on there. okay?
Either way,
So the frictional force between the penny and the beam is just equal to the force required to provide the centripetal acceleration. No more, no less. Just like as I tilt this thing more and more, the frictional force required to hold it on there keeps increasing. Okay? So frictional force is just what's required, not more, not less. At a certain angle, not too much greater than this angle, this thing would start to slide. Friction would be incapable of providing the necessary force. As this thing speeds up, you require more and more friction. More and more frictional force. There's a limit to how much frictional force, and if we exceed that limit, there it goes. Okay? That makes sense? So that's the meaning of my statement. Now that's kind of an important idea because you're going to need to use that in the near future. Okay, well, we're not going to try to determine coefficient of friction today. We're just going to try to calculate what this acceleration would be at this speed, this angular velocity. Okay? Now, at 2 revolutions per second, how fast is the wood block or the penny or whatever it is actually traveling? What's its speed, v? Its angular velocity is 2 revolutions per second. How fast does it move? Well, think about it for a second, and I'm going to tell you. How would you figure out how fast it's moving? Okay, now, at 2 revolutions per second on a 25 centimeter circle, that means it goes around the circle twice. How far is it around the circle? 2 pi times the radius, right? Okay? Well, a revolution corresponds to moving distance 2 pi r, right? Well, that equals then, I'll keep it this way, 2 times 2 pi times 25 centimeters per second equals then 4 pi times 25 centimeters. So this multiplies out to 100 pi centimeters in the numerator, second in the denominator. And that's a very straightforward calculation. It's, pi is 3.14 approximately, so it's approximately 314 centimeters per second or 3.14 meters per second. Now, a more approximate calculation, which would be appropriate because we're dealing with friction, would probably round that to just 300 centimeters per second or 3 meters per second. So we're actually going to calculate this with that kind of round off. So now, what is the magnitude of the centripetal acceleration? V squared over r. Okay? Well, calculate V squared over r for me.